Good day to all. Today we are going to see about that nodes analysis. This is for the Kirchhoff's current law. Analysis using the Kirchhoff current law to solve the voltage at each common node of the network and hence determine the current through and voltage across the elements of the network. See what we have to do in that nodes analysis. The procedures of the nodes analysis is, first we have to determine the number of common nodes and the reference nodes within the network. Then we have to assign that current and its direction to each distinguished branches of that nodes. First one is we have to determine how many common nodes. Then we have to determine the current direction, which flow the current is, because according to this current flow only we will get the particular sign, whether it is a positive or it is a negative. So we have to assign the current for a direction. Then KCL, Kirchhoff's current law, we have to apply KCL at each of the common nodes in the network. Then that we have to find out that equation, then we have to solve that particular equation. Solve the resulting simultaneous linear equation for the node voltage. Finally, determine the currents through and voltage across the each elements in the network. We have to determine the I and V. These are all the steps for a nodal nodes analysis. See, we have one exercise over here. Find the current flow through each resistor using node analysis, the circuit below. Here is 10 volts, here is 10 ohms, and R3 is 40 ohms, and R2 is 20 ohms. Here V2 equal to 20 ohms. We have to find out the current flow through the each resistor with the node analysis. First, what we have to do, we have to give that what I said before. Just remember those steps. What we have to do, first we have to determine the number of common nodes and the reference node with the network. Here there is a one common node which is VA, and another one is we have a reference node, because if it is any point joint 2 or more, we will take as a node. So here this one node is there, and here also another node is here. Then we have to assign the current and its direction to each distinguished branch of the nodes in that network. Right? So we have to give the direction. For here it is V1 R1, then the current must be here is I1. Thus current flow through this positive to negative, so the current flow will be here like this. Then here V2 is positive over here and R2 is here, so this current is I2. It is going from this direction to this direction. Then this is the outward direction, which is I3. Here in that particular VA node, the incoming current is I1 and I2, and the outgoing current is leaving current is I3 over here. Then what we have to do, we have to just apply KCL at each of the common nodes in the network, which is equal to I1 plus I2 equal to I3, because this I1 and I2 is incoming current of that node VA, and I3, here I3 is leaving current of node VA. Then we have to draw the diagram. What is that? We have to give the equation for that equation behind this diagram, circuit diagram. As we know already, the Ohm's law formula is V equal to IR. So, what is I? I is nothing but V by R. We have to remember always this formula, as I said before. This Ohm's law we will use in everywhere in that in electrical. So, V equal to IR. If it is we want to know about the I, that is equal to V by R. We will substitute this over here. See, if I want to take first I1 means what I have to do, that is I1 equal to V by R, which means V1 by R. Here, what is the resistance over here? It is 10 ohms. If I want to take a voltage across this resistance, what I have to do? For that, we will take voltage minus resistance, right? That is, we have to take this as a current. So across this resistance, what will be the voltage? Voltage minus VA. So likewise, we will return this 10 volts minus V1, 10 volts minus VA divided by 10. Thus V by R plus 20, where it is 20. Here it is 20, come over here. So this 20 divided the 20 minus V2 divided by 20, which is equal to VA by 40. That is come over here. Then we will take this 1 as a common, in the sense what we have to do, 1 minus VA by 10 plus 1 minus VA by 20, which is equal to VA by 40. So we will take a LCM over here. For that we will go this negative sign to there. So what will happen? VA by 40 plus VA by 10, then VA by 10, which is equal to 2, because that 1 and 1 will have a 2, which is equal to 2, right? Then we have to take that V as a common here. So 1 by 40 plus 1 by 40 plus 1 by 20, which is equal to 2. So VA is equal to, if we are taking a 40 as a LCM over here, 7 by 40 equal to 2. So VA equal to 42 into 2, that is 80 divided by 7. So we will get a VA is 11.428 volt. From that VA, we will find out that IA1, because already we have a VA over here instead of that I1. So we will write this I1 is equal to 10 minus VA is 11.428. We will substitute that 11.428 over here divided by 10, which is equal to minus 1.428. Here minus 1.428 divided by 10. That will be the result of 0 minus 0.413 amps for that I1. For I2 also we will have the same, like here 20 minus VA divided by 20. So 20 minus VA, what is that VA? VA is nothing but 4.28 divided by 20. So we will put 0.429 A. Here it is come for, what will come, 20 minus 11.428 divided by 20, it will come around that 9 minus 9 point, sorry, plus 9.428 divided by 20, then we will get a 0.429. Likewise for I3, what we will get? VA by 40. So 11.428, this is a VA divided by 40. we will get the I3 value equal to 0.286. Like this, we will have all I1, I2, I3 value with that nodal analysis. Thank you.